Here we are practicing a little bit more implicit differentiation. We're asked to find dy dx and the slope at 0, 0 for a couple of expressions here. For part A, we have tan xy equals x plus y. So if you're starting to get comfortable with implicit differentiation, pause the video and try this one out on your own. See if you can work it out, and then we'll try it together. Okay, so we're taking the derivative with respect to x here, so dy dx. So that tells us every time we take the derivative of x, it's going to be the regular derivative, and every time we take the derivative across a y here, we'll tack on a y prime. Why do we do that? Well, we're considering y is really some function of x, right? And so it's simply the chain rule. Okay, so let's get started on this derivative. We have tan xy, so we're taking the derivative of both sides here. So let's, I guess, put that in. Alright, so we're taking the derivative with respect to x of both sides, d by dx. You could also just prime both sides. Okay, what's the derivative of tangent? Well, it's secant squared. Secant squared of what? Well, whatever's already in there, right? We're just applying the chain rule here. Chain rule says take the derivative of the outside, leave the inside alone, and then take the derivative of the inside. So now we have the derivative of xy. We'll use the product rule on that. Okay, remember the product rule tells us that the derivative of AB, so AB prime, is A prime B plus B prime A. So in the case of xy, it's, let's see, derivative of x is 1 times b, so A prime B is 1y plus b prime. Well, now this is a y, so it would be 1y prime, because we're taking the derivative with respect to x, so we tack on that y prime times a, which is x in this case. Yeah, so in a nutshell, anytime this variable down here doesn't match the variable you're taking the derivative with respect to, you tack on a prime of that variable. That's kind of the shorthand way of approaching the implicit differentiation in this example and any other example. Okay, equals. Now we're taking the derivative of the right side. So note that that derivative applies to the entire right-hand side there. So I put parentheses in there. Okay, we have the derivative of x. All right, well, derivative of x is 1. And then, for the same reasons as before, the derivative of y is y prime. Or you can think of it as 1 times y prime. Okay, and just like that, we are done with the calculus. The rest of this entire exercise is algebra. What are we solving for? Y prime, which is dy dx. Right? I don't like to write dy dx over and over again. You can feel free to do that. To me, it starts to make the problems look really busy and cluttered if you try to write dy dx every time. So I like to focus on just y prime, but certainly feel free to write dy dx instead of y prime every time. Okay, well, how do we solve for y prime? Right, testing our algebra skills here. What I'm going to do is I'm going to distribute the secant squared xy to both of these, and then I will work to get all the terms with y prime on one side and everything without a y prime on the other. That will allow us to solve for y prime. So let's do it. Okay, so here we have y secant squared xy plus y prime x secant squared xy equals 1 plus y prime. Let's get everything with a y prime in it on one side, so I'll subtract off the y prime here, and I'll subtract off this whole other term y secant squared xy from both sides to get everything else on the other side. So we have y prime x secant squared xy minus y prime equals 1 minus y secant squared xy. You can put those in parentheses or not. It actually doesn't matter. I think it's pretty clear that xy is inside the secant squared. What do we do now? Well, we factor out the y prime from this left-hand side. Look at that. Whoops, not quite there yet. We have x secant squared xy minus 1. All right, and then the right-hand side stays the same. And what can we do next? Well, we can divide out everything and solve for y prime. So here I will divide everything by this whole expression here, this x secant squared xy minus 1. Divide that out, and that gives us y prime, which I will put here. Y prime is then 1 minus y secant squared xy. Okay, all over x secant squared xy minus 1. Finally, we want to find the slope at 0, 0. That was part of this exercise after all. To do that, we just plug in 0, 0 for x and y. So y prime evaluated at 0, 0 is how we can express that that's what we're doing here. Well, if we plug in 0 for x and y there, we get negative 1. Okay, moving on to part B, we have cos y squared plus x equals e to the y. So if you can follow what happened in part A, I would venture that you'll be able to do part B. So pause the video, try that out, see how it goes. Well, we need to take the derivative of both sides, just like we did before in part A. So let's do that. So we have d by dx of the left equals d by dx of the right. That means every time we see a y, we're going to tack on a y prime. If we're taking the derivative across it, that's the chain rule. Okay, so let's do these derivatives. Cos y squared, well, the derivative of cosine is negative sine, and we leave the inside alone, times the derivative of the inside. So this is negative sine y squared times the derivative of y squared. Derivative of y squared is 2y, and then we need to add on that y prime since we're taking the derivative with respect to x. All right, moving on to our next term, we still have this plus x hanging out here. Well, that derivative is pretty nice. It just becomes plus 1. Okay, equals. Now the derivative of e to the anything is e to that thing times the derivative of that thing. So the derivative of e to the y is again e to the y. But now we need the derivative of this y business, and we know that that is indeed y prime. Okay, well that wraps it up for the calculus. All algebra from here out, we need to solve for y prime. Let's get all those y primes on one side, everything without a y prime on the other, then we'll factor out the y prime, and then we'll divide to solve for y prime. So I'm going to add this term to both sides. Right? That way I can keep things positive. I'll get all the y primes on the right side. Feel free to get them on the left side if you're more comfortable with that. It doesn't matter. That gives us 1 equals e to the y prime, plus, I'll rewrite this a little bit, 2y y prime times sine y squared. Well, now we factor out the y prime. This is the whole deal here. You want to get that y prime isolated. That leaves us with e to the y plus 2y sine y squared. And then we divide out all of this, right? So we divide out this entire term here. Divide both sides by that. Divide the 1 by it as well. That will give us, then I'll just write the y prime on the left now. Y prime equals 1 over e to the y plus 2y sine y squared. And again, if you recall, the original problem asked us to find the derivative at 0, 0, at that single point. So let's do that. Plugging in 0, 0, well, sine of 0 is 0. E to the 0 is 1, so it's simply 1 over 1, which is 1.